It's a crisp winter evening. There's frost racing around the edge of my window, the one that makes the whole world feel quieter. As I often do so, I step into my back garden, not to stargaze dramatically, but just to have a quick survey of the clouds. Clear sky, good visibility. As I'm standing there looking at the constellations above my head, I notice something different. Soft green ripples of light across the sky. Aurora in Dublin. I run upstairs, probably screaming something incoherent, and drag my parents out to the window. Now, my parents are curious people, yes, but they're also ordinary. They're not very much interested in astronomy. However, they said, let's drive. If we're doing this properly. So we drive an hour away, chasing darkness. As I'm standing there watching the sky dance above me, something dawns upon me. You do not need to be a scientist to be moved by the universe. You just need curiosity. And this curiosity is the reason I do what I do. Now, if I asked you where you've seen aurora before, you'll probably say Norway, Iceland, maybe Scotland, your iPhones. Kids and their phones these days. But what if I tell you one of the most greatest spectacular auroral displays in our solar system doesn't happen here on Earth, but it happens somewhere far away, on Jupiter. Jupiter's aurora isn't just brighter than ours, it's hundreds and thousands of times more powerful. And unlike Earth, this aurora isn't being created by the sun. It's being made by something small, something cheeky, a moon. Io. Io is a volcanic moon, one of the most volcanic places in our solar system. Lava fountains shooting hundreds of thousands of kilometers up into the sky. Red, yellow, orange, because sulfur covers the entire surface. And when this volcanic material spews up in the sky, it doesn't just fall back down. It gets caught by Jupiter's large magnetic fields and swirls around the tops, creating the aurora that we see. Now think about that. Aurora and moons. Moon, something that we are told is passive and small, but it is changing an entire system. It's changing an entire planet. And that stuck with me. Because if a moon can be changing Jupiter's atmosphere, why couldn't a moon change something else's atmosphere? And that brings me to the research I conduct. I look at brown dwarfs. A brown dwarf is a celestial object that's bigger than Jupiter but smaller than the sun. Just like Jupiter and Earth, it also has aurora on its poles. But unlike Earth, it doesn't have a nearby star spewing particles at it, creating this aurora, because it's alone in space. That's interesting. Why is there aurora there if there's nothing there to make it? And that's when I remembered. Io. Because if a volcanic moon around Jupiter can create its aurora, then a hidden exomoon, a moon outside of the solar system, can be creating the aurora that we see on the brown dwarf that I was studying. And that became my hypothesis. There's a moon around this brown dwarf, and it's orbiting it, and it's interacting with its magnetic field, creating the aurora that we see. That sounds simple, doesn't it? It's really, really not. What I did then was I went out and I got data from the James Webb Space Telescope. The James Webb Space Telescope is a telescope outside in space that gives us data. Now, usually, you might think that these are pretty pictures, but it's actually light. And that's where it gets complicated. Think about a distant street light. When something passes under it, even something tiny, it creates flickers. And we can analyze these flickers in the lights to see whether there is something there. And astronomers use the same thing. It's called the transit method, the one that you see behind me. We can observe how the brightness changes to see if there is something in front of it. However, brown dwarfs make this very tricky. That's because they are always exhibiting stormy weather. Their light is always constantly changing because of clouds coming up, storms, and many other things. They have ever changing weather. So that makes my life harder. I don't know if there is a moon there or if it's just clouds blocking the light. But here's the thing about science, we have really, really cool stuff. One of the things that we could do is when light travels through space, it gets split up into the different colors of the rainbow. Different clouds may turn up in different colors, but moons turn up in every single color. And I use this to create, now this might scare you, a light curve. It's just how the brightness is changing with the time. And I analyzed these 3 different light curves to see whether the dimming is because of clouds or whether it's because of an exomoon. It took a long time, and I'm still currently in the process of doing this. I'm trying to do it in different ways. But the definite answer that we've gotten is that there's nothing there. But here's the thing about science. Not finding something is still finding something. Because this helped me improve our tools, we improved our search, and we made science more accessible to everyone else, like you guys here today. In the coming years, we can use this research. The Habitable Worlds Space Telescope that NASA is launching can look for Earth-like objects. The ELT, or the Extremely Large Telescope, will see beyond and in greater detail than we've ever seen before. And all the research that we're currently conducting can be applied and used exactly on the new data sets that we get, essentially making our lives easier later on. Now, when my parents were standing there under the clouds and underneath the aurora, they weren't thinking about magnetic fields or Jupiter or brown dwarfs. What they were feeling was wonder. And this wonder drives curiosity. And curiosity is essential for humanity. Curiosity built telescopes. Curiosity built James Webb Space Telescope. Curiosity is evolving science, and curiosity is the reason that we're all here today. So, I have one request. Next time you're outside and it's dark, which it usually is in Dublin, go outside and look up at the sky. Drive somewhere far away and just look up and appreciate our place in the universe. And maybe, just maybe, when you're seeing a ripple in the sky, it might make you ask more questions. And this question might be the start and change everything for you. Thank you.